trying to understand physics? Well, one of the reasons is that probably you didn't understand the fundamentals of physics. So, today in this video, I'm going to simplify one of the most fundamental and important topics in physics, that is base quantities, physical quantities, submultiples, and multiples. So, enjoy this video and hopefully it will be helpful and you will subscribe, like, and comment to this video. Let's get right in. A physical quantity is a quantity that can be measured. On the contrary, we have what we call abstract quantities. Abstract quantities, these are quantities that cannot be measured. For example, we have fear, we have love. Those quantities cannot be measured and expressed as much as physical quantities can be. Physical quantities, we're talking about length. Length can be measured and expressed in meters, miles, kilometers, whatever it is. Now, physical quantities are divided into two groups, base quantities and derived quantities. Base quantities, these are quantities that are independent of other quantities. Derived quantities, these are quantities that are quotients and products of base quantities. We'll look at the derived quantities later on. Let's look at the base quantities with their SI units. Base quantities, we have 7 base quantities, that is thermodynamic temperature, with its SI unit Kelvin, the electric current, its corresponding SI unit length, meter, the mass, the kilogram, time, the second, amount of substance, its unit being the mole, luminous intensity, its SI unit being the candela, with the one L there. Then derived units, as I've mentioned earlier, derived quantities are products and quotients of base quantities. Take for example velocity. The equation for finding velocity is the distance covered per unit time, or the displacement covered per unit time. So that is a quotient. That is, we have a division sign there, so it's a quotient, right? Let me just put it out there. Velocity is equals to displacement. Change in displacement is represented by S over the time taken. So that's the quotient. That's how we represent quotients. Now therefore it qualifies as a derived quantity because it has a quotient. We have, for example, force is equals to ma. This is a product of mass and acceleration, therefore it qualifies as a derived quantity. We have momentum p being equal to mass by the change in velocity, or the velocity at that particular point. This is a product. Same with the units, the SI units, they are quotients and or products of the base units. That is just about it for the base units and the derived units. Let's move on to the multiples and the submultiples that we're going to be dealing with in physics. In physics, we are going to be dealing with very small numbers or very large numbers, which the multiplying factors, the multiples, would come in handy. For example, you're dealing with a number that has a multiplying factor of 10 to the power negative 12. You wouldn't want to write all the 11 zeros on paper. So it would be much more easier to just write the prefix, that is the pico. If it is maybe wavelength, that is in picometers, you just write the PM. If it is maybe nanometers, nm, rather than writing the whole number, So our multiples, they make life much more easier in physics when dealing with large numbers or very small numbers. So this is a table, or it's not a table because I didn't draw the rows and columns, but you get it. This is a table of the multiples and submultiples that are common in A-level physics and that we're going to be using. So I'm just going to run through them with the pico, the nano, the micro, the milli, the centi, the deci, the kilo, the mega, the giga, the tera. Now we're going to have prefix, symbol, and multiplying factor. So the symbol for the pico is the small letter p, the multiplying factor being times 10 to the power negative 12. Then we have the nano, the symbol being a small letter n, and the multiplying factor times 10 to the power negative 9. The micro, the symbol being the mu, it's sort of like a U with a tail there, and the multiplying factor being times 10 to the power negative 6. Milli, the symbol small letter m times 10 to the power negative 3 being the multiplying factor. The centi being the prefix, we have a symbol small letter c, the multiplying factor times 10 to the power negative 2. The prefix deci as a symbol of small letter d, multiplying factor times 10 to the power negative 1. Kilo, that should be a capital letter K, the multiplying factor times 10 to the power 3. Mega as a symbol of capital letter M, and multiplying factor times 10 to the power 6. Giga, the symbol is a capital letter G, multiplying factor times 10 to the power 9. The tera, the symbol is a capital letter T, multiplying factor times 10 to the power 12. So when you hear someone saying, I have a laptop and my laptop is 1 terabyte, right? It's 1 terabyte. That means it has 1. We say the tera is a multiplying factor of times 10 to the power 12 bytes. If a song has 3.4 megabytes, 3.4 MB, that means it has 3.4 megabytes times 10 to the power 6 bytes, right? So if the length is 15 centimeters, that means it's 15 times 10 to the power negative 2 meters, like that. So if we want to convert a particular length from one submultiple to another, we would have to have knowledge of these particular submultiples. For example, you want to convert 100 nanometers to meters. That's just 100 times 10 to the power negative 9 meters. And that's it. You simplify that with the calculator. Now, how about if I want to convert maybe, let's say 100 square centimeters to square meters? How do I do that? We know that 1 centimeter is equal to 1 times 10 to the power negative 2 meters. So that's going to be 0.01 meters, like that. That's our 1 centimeter, right? 1 meter squared is equals to 1 meter times 1 meter. So we're going to have 0.01 times 0.01, and that is going to be 0.0001 square meters, like that. So 1 square centimeters will be equal to that. What about 100 square centimeters? Let's just multiply this by 100. And I would get, this is 1, 2 decimal places, 1, 2, 0.12 the 0, that's going to be 0.01 square meters, like that. That is 100 square centimeters. Now this is one way to calculate. I'll show you an easier way. We said 100 square centimeters to square meters, right? We know that our centi is times 10 to the power minus 2. So I just put the minus 2 there. Then like 100 square centimeters to square meters, right? I just put the minus 2 there. It's just a trick, right? So I multiply the minus 2 and that 2. that's minus 4. So that's going to be 100 times 10 to the power negative 4 square meters. Then you simplify this. So this is just a trick. If I had been given 100 cubic centimeters, the cent is just negative 2. Then minus 2 times 3, that's negative 6. So I'm going to get 100 times 10 to the power negative 6 cubic meters. If that was a 100 nano cubic meters to meters, this is a negative 9. So 9 times 3, that's going to be 27. So that's going to be 100 times 10 to the power negative 27 cubic meters. That's how easy it is, So it's just a trick to make your life much more easier when doing your calculations and converting maybe from one SI unit to another that is required in your particular question, or to suit all the other data that you're given so that you can calculate properly. I hope you enjoyed, and it has been much more simpler than before. Don't forget to subscribe, like, and comment to my channel. Go and enjoy your physics A level.